right? So these are the four shapes: straight line, a circle, an ellipse, and a parabola. Parabola looks like what? A max or min, right? Right? The circle looks like a what? A circle, right? And what does the ellipse look like? Right, so a kind of elongated circle, right? And then when the parabola, you kind of know it from quadratics, okay? The parabola could be shaped like that, or the parabola could be shaped like this. Okay, all those are parabolas, but it's based on the conditions, right? So because it's a straight line, I just want to give you the straight line rules. These are your Form 1 straight line rules. Distance between 2 points, midpoint, gradient, parallel lines are equal, and so on, right? But if you don't recognize any, just copy them down. What we know about perpendicular gradients again? Product is -1. Write it down there. Perpendicular lines, the product is -1. All right. Circles. I want to go over Form 5 circles. Write down everything here, right? So a circle, the general equation of a circle is x minus a squared plus y minus b squared is r squared. The center is AB and the radius is r. And then there is the expansion of this that looks like this. So if you see the next form, x squared plus y squared plus 2fx plus 2gy plus c, then the center is minus f minus g and the radius is that. F squared plus g squared minus c. Okay? There's a next thing that we need to remember. Sometimes they ask us, you'll remember this from Form 5? They like to ask you to find the equation tangent, right? And the tangent is always a what? A straight line, right? And it's always perpendicular to the radius. So in order for you to get the equation of tangent, you need to get the gradient of the radius, right? And since they are perpendicular, you use this rule here. -1 over the gradient of the radius. And then you use the formula to find the equation of tangent. Quick question. Suppose I wanted to get the equation of the normal. So really and truly, the normal is perpendicular to the tangent. So it's like this, drawing a line out here. Right? So the equation of the normal is the equation of the radius. Okay? Copy that down. Right here, two quick examples. We're not doing these. I'll give you 2-point passive, but that's not right. So if you look here, they ask you to find the center and the radius of x squared plus y squared minus 4x plus 6y is 2. What they did? They compared to the general form and find f and g. And then how do you find radius? You use the formula, square root of f squared plus g squared minus c. All right? So that is an example from what you would have done in Form 5, right? All right. The part I would like you to try for me, find the equation of the tangent at 3, 1, right? So at some point on the circle, you know the center, find the tangent at that point, 3, 1 for me. So what you all got for the gradient? So you remember the gradient of 1 is 4. And the next gradient is that. So when you carry the 4 here is -1. Or you could just use what? Negative reciprocal, right? Flip over the 4 and change the sign. So the gradient is -1/4. Right? And then plug it in the equation and you all got what? +7 and 4. Nice. Right? I just multiplied by 4 and get the answer, right? Okay? So that is a quick review on how to do this, right? There are some quick things that I want to talk to you about, right? Here's what happens sometimes. Sometimes they will ask you to find the equation of a circle, but in finding the equation of this circle, all they're going to do is give you 3 points, P, Q, and R. How you'll get the equation of a circle? Ignore my diagram. They're wrong, right? So suppose I gave you something like this. And I said, well, Shivish, help me out here. Find the equation of this circle, right? So you have P here, you have Q here, and you have R here. How do I find the equation of that circle? All right. So let's go with something a little bit long, but something we could probably do. And we know the general form. The general form is x squared plus y squared plus 2fx plus 2gy plus c is 0. So if you look here, right, we need to get this equation, right? But in order for us to get the equation division, what we need f, we need g, and we need c. Okay? But we have 3 points on the circle. So this point has an x and y value. This point has an x and y value. This point has a x and y value. 3 unknowns, right? So how many equations we need? 3. So you can take the point P, put it in here. That will give you one equation. Take the point Q, put it in here. That will give you a next equation. And take the point R, put it in here, and that'll give you a third equation. And then you solve the 3 equations simultaneously to find F, G, and C. That's method 1. Okay? It's plenty. Just make a note of this, method 1. The subheading is finding the equation of a circle given 3 points only. Right? Make a little sketch of this. They didn't give you anything. They didn't give you the center. They didn't give you diameter. They didn't give you any of those things. Right? Let's take a look at method 2. To me, method 2 just as long. Huh? Watch method 2 here. Here's what method 2 is. Method 2, the first attempt is to get the center. So they found 2 equations. They found P and R. They find equation P and Q. And then, for each of those lines, they found the perpendicular bisector. Right? So they found the perpendicular bisector here. And they found the perpendicular bisector here. Right? My diagram not drawn to scale. And then they solve those 2 equations. Let's call them L1 and L2. They solve those 2 equations simultaneously. And where they meet is the center. I think I have that written down here for you. Right, just make a note L1 and L2 are perpendicular bisectors. Once you have the center, what you can do after that? After you have the center, you can use that to find the length of the radius and then the equation of the circle. All right. So method 1 is plug in P, Q, and R, 3 equations and solve. Method 2 is to find the perpendicular bisectors of 2 lines connecting the points and then solve them simultaneously. Let's try one, right? So I've given it 3 points on a circle. Let's see if we could follow all the steps, right? I am going to do method 1. I would like you to substitute all the points in x squared plus y squared plus 2fx plus 2gy plus c is 0. Right? You substitute all the points in there and you will get 3 equations that we're going to solve. When you're solving simultaneously, right? What you always try to do? Eliminate a variable, correct? When you have 2 variables, you're trying to eliminate to get 1. So if you have 3, what you'll do? Try and eliminate F, G, or C. Based on how your equation's looking, which one you think is the best one to eliminate? C, very good. Once you eliminate C, you can figure out F and G. Try that there. Get your equations, let's see how it looks. So one of the ways to eliminate C is they could subtract, let's say, equation 1 from 3 and 2. Or you can make C the subject in equation 1 and substitute. Anyone could work, right? But I will do 2 minus 1. And then I will do 3 minus 1. 10 minus what? 4. I got 6F. 12 minus 6. I got 6G. Then the C will cancel. Minus 61 minus 13 is how much? Minus 48. Nice. Everything has 6's and I can just divide it out. Yeah, if I divide by 6, F plus G is equal to minus 8. Right? Let's call that equation 4. You'll recognize what happened when you substitute 3 and 1. Sorry, minus 3 and 1. Yeah, you just get an F. So it worked out real nice there. 16F minus 4F is 12F. 6G minus 6G is 0. C minus C is 0. Minus 73 minus 13 is minus 60. So we know that F is equal to minus 5. Right? What you all got for G? Minus 3. What you all got for C? C is 9. Okay, nice. So we have the equation, right? X squared plus y squared minus 10x minus 6y plus 9 is 0. All right? So that is a quick example. And in case you see something like that, what to do, right? Somebody got C as 25. Somebody else got 25. Let me just check it out. So C is minus 13 plus 20 plus 18. So that's 5, yeah, 25. All right. Something else that's a little bit new is sometimes we have to take a circle and write the circle in a parametric form. So write it in a different form in terms of theta in this case. Do you remember what's parametric? When you have an equation in terms of a next variable. What is called x squared plus y squared plus 2fx plus 2gy plus c. What type of equation is that? Beginning with C. Cartesian. When you have x and y, it's called the Cartesian form. All right? So let's take a look at how to write the circle in a parametric form, right? So watch this here. Let's say I give you a circle, right? And on the circle, I'll give you a few things. I'll give you the center. Let's call the center AB. And then we have a point all the way here, P. Let that point be XY. I want to show you something here on the axis, right? Let's pretend it looks something like that. Something like that. What is called this length here? Radius. Nice. So we know that, right? Let's draw down a line here. This value is A. This value is B. This value here is what? X. And this value here is Y. Nice. So we're going to try to introduce a new variable now. Let's call the variable theta. All right? So I'm going to create this triangle here. I'm going to try and draw it in blue to highlight it a little bit. Here and here. What is the opposite length there? That's y minus b. This whole thing is y. This little piece is b. So this piece here is y minus b. What's this length here? X minus e. So quickly, what is sine theta? Opposite over r. So if I rearrange that, can I get an equation for y? Yeah? Y is equal to b plus r sine theta. What is cos theta? Cos theta is adjacent over hypotenuse. So therefore, x is what? X will be a plus r cos theta. And there you have it. This and this is the parametric equation of a circle. So if you have x and y in that form, you have a parametric. Every center is 0, 0, then A and B is 0 and 0. Right? What I gave you is the general form, regardless of what A and B is. Right? You don't have to prove it, but you have to be able to watch an equation and know it's a circle. Anybody remember how to go from parametric back to the equationary circle? So basically, here's what you're thinking about. How do I remove theta? Because parametric is where you introduce that new variable, right? So Cartesian is where I have to get rid of that variable. So I've given you an example, and I am giving you the parametric equations of a circle, right? It becomes a little bit harder when you learn the other parametrics, because they will just give you the parametric and you have to figure out what it is, right? But suppose I give you something like this. The x was the cos, right? And the y was the sine, right? Step 1, you could find cos theta. Step 2, you could find sine theta. Step 3, you could substitute in cos squared theta plus sine squared theta is 1. And then magically the theta has disappeared. X minus 5 and 2, right? And then sine theta is y minus 3 and 2. And then when you substitute, you're going to get x minus 5 and 2 squared plus y minus 3 and 2 squared is equal to 1. And if you square it out, you'll get x minus 5 squared, y minus 3 squared, and you have 4 underneath. So you can multiply everything by 4. And you'll get something like that. That is your Cartesian equation. You don't have to expand it out. If you want, you can do it. I just wanted to get it Cartesian. If you want to get it general and expanded, go right ahead. All right? So that is where this equation came from, right? Once you see it in that form, you know you have a circle, right? The key thing, because an ellipse will look just like this, except it will not have a R here. It'll have 2 different values, okay? Because it doesn't have a radius, right? So it's important that you can identify the circle from the ellipse. If I give you this, right? Now that you know that this is a circle, can you just watch it and figure out the radius? The radius is root 10 of 10. R is root 10, okay? Because remember the general form is R cos theta plus A, right? So the radius is this, and what's the center? Center is minus 3, 2. They just rearrange it, okay? Instead of minus 3 plus root 10 cos theta, they have it the other way around. So that is the first thing about this circle. Do I show you the ellipse today, boy? Let me just talk about it, right? While it's in your mind. What you will recognize about an ellipse, that it doesn't have the same distance around the circumference. The distance will change. So there is something called a minor axis and a major axis, right? The minor axis in this case is the parallel to the x, and the major here is parallel. So once you have the minor and the major, you just connect them up and you get the ellipse. So we're going to focus on those things next day, right?